Hey guys, so getting into lesson 5.5, we're going to take a look at the law of sines. You've probably already seen the law of sines. This generally gets covered in honors geometry, and potentially you might have seen this in some algebra 2 as well. Just depends on what all was covered in your course, but so some of this should look familiar to you. We use the law of sines and the law of cosines for working with non-right triangles. So that's really what these guys are geared towards, is if we have a triangle that's not a right triangle, we can use these when the other things are not available to us. All that we've been doing so far this chapter has involved right triangles, and so we've had things like sine, cosine, and tangent. We've had Pythagorean theorem, we've had 30, 60, 90s, and 45, 45, 90s. We've had all those things, but those are all based on right triangles. So now it's like, so what do I do then if it's not a right triangle? Right, and that's where something like the law of sines or the law of cosines comes in. So we're just going to fill in this first part here. So you can see the triangle that's been given to us. Just as an FYI, you've probably seen this before, but sort of the standard labeling of a triangle is they will use capital A, B, and C to represent the angles or the vertices. And then the lowercase letters would be the sides across from those angles. So if this is angle A, then across from that would be lowercase a, which represents side A, so on and so on. So what we're looking for in this is basically to find whatever is missing, right? So I am missing the third angle right here. I'm also missing two of the sides. Well, the third angle we could find pretty easy. We know that all three angles of a triangle add to 180. So if I just subtract, let's see, what would that be? 88. So if I subtract 88 from 180, then I would get 92. So we know angle C right off the bat. I do always encourage you guys to fill in your diagrams, because as we start creating these ratios and proportions, it really helps to have a good visual of what's going on here. So here's how the law of sines works. Really simple, actually. It's just a proportion, right? So I have a ratio on the left, a ratio on the right. Slap an equal sign in between those and you have a proportion, right? So we are going to do the sine of an angle over its opposite side is going to equal the sine of another angle over its opposite side. The letters are irrelevant. This could work with an A, a B, a C, whatever. All that really matters on this is that whatever this angle is, this is the side across from that angle, and then the same thing has to be true within this ratio. So we're just going to fill in the left side ratio on this. So if we said the sine of 53 degrees, that is across from the side that equals 10. So on top, we're going to say sine 53 over 10. And then here is just another combination of an angle and its opposite side. And so we're just going to solve this proportion. Oftentimes, it seems like people really prefer to cross multiply in order to solve a proportion like this. So we'll take that route. So I'm going to multiply b over to the left. So b sine 53. I'm going to multiply my 10 over to the right. So 10 sine 55. And then the rest is going to be calculator. Obviously, I'm going to have to take my sine 53 and divide that over in order to get my answer here. So we're just going to write this out. So I'm going to say b equals 10 sine 55 over sine 53, because that's what's going to go into my calculator. And we'll get an approximate value for him. So let's just punch that one in. We are in degrees right now. So let's make sure that is correct. So if I type all that in, we got 10 sine 55 on top, sine 53 on bottom, and we got about 10.3 for side B. So let's fill that into our diagram. Always a good thing to do. So now looking for my one last side, again, I'm just going to pair up another combination of numbers. I always recommend using values that were given to you. So I'm going to stick with my sine 53 over 10 as one of my ratios, and then my other ratio is going to be the unknown that we're trying to find, right? All right, and I am noticing over here that I threw in the wrong number on this. I should have been 72. You guys probably already noticed that. So those guys should have totaled 108. So that's what I was subtracting from 180. So that should have been 72. So anyway, so that's where this second ratio is coming from. So now we're getting sine 72 over c. And again, we can just cross multiply to solve and get that missing side the same way that we did on this one. All right, let me flip. So here is an interesting scenario that we are running into on this side. They call this the ambiguous SSA case or scenario. So here's what's going on with this one. So we have our standard triangle, and in this problem we are given two sides and an angle, right? But it's not the included angle. It is in the order of a side-side angle ordering within the values. So in this case, there's an issue here. The issue is we don't know if this segment was drawn this way or if it could be drawn this way. So here's what I mean by that. So I drew it in two different ways. So if all I was told is that I have two sides that were 8 and 10, and the angle across from side 10 was 38 degrees, right? That's all we know. So there was no diagram to begin with. So if that's the information that I was given, if you look at the information over here, you can see that certain triangles could be drawn two different ways. Here's the first thing you're looking for. If the side across from your angle is larger than the adjacent side to the angle, then you're kind of safe, right? In other words, there's only one way to draw this triangle. So again, it's the opposite side is larger than the adjacent side. Then you only have to work with one triangle. It's the only way to draw it. However, if the opposite side is smaller than the adjacent angle, then potentially we have two triangles here. So in other words, I could draw the 5 here, or I could draw the 5 here. And you see what I'm doing on that is, in this scenario, this is an acute angle. But in this scenario, it's an obtuse angle. Well, either way I drew it, I still kept all the values the same. That's why it could be drawn either way. I still have 5, 8, 38 as my combination of numbers. This is still 5, 8, 38 degrees, is the same combination, but how do I know if this is supposed to be the obtuse version or if it's supposed to be the acute version? Well, we don't know. So in other words, we get to do both. So that's what's going on with this next one. But hang on to this rule, because this is the guide as to how you know if it's just one triangle or two possible triangles. So here's what we ran into with example 2. So we're given two sides and an angle. And again, the order that we're reading this is a side-side angle scenario right here. Okay, and we're seeing the case where on this one, the opposite side is larger than the adjacent side. So in that scenario, there's only one triangle that could be solved. So as I look at this one, and this is what they're saying right here, is this is not the ambiguous case for the rule that I just pointed out. So we would go on to solve this one just like we did the previous problem. We're going to set up our law of sines proportion. So we're going to say sine 27 over 12 equals sine of b over 10. So here's the proportion that was set up. So if I were to multiply my 10 over to the left, here's what that's going to look like. So I got 10 sine 27 over 12. So one thing to remember on this is, how do we ever solve for an angle, right? In solving for an angle, we always need to use the inverse function. So I'm going to have to take the inverse sine of this in order to figure out what angle B is. So if we did that, let's throw that into the calculator, see what we get. So let's take the inverse sine of that big fun fraction right there. So 10 sine 27 over 12. And we figure out that our angle is about 22.2 degrees. All right, so I'm going to fill that into our diagram. So we already know how I would come up with angle C, right? If I subtract these guys from 180, that's going to give me angle C. So that's always the easiest one to find. Let's do that real quick. So I'm going to take my 180 minus 27 minus 22.2, and I get 130.8. So there's our third angle. All right, so the last one we got to come up with is side C. So it's going to take one more proportion. Again, I'm going to say sine 27 over 12 is equal to the sine of 130.8 over side C. That's our unknown. We're going to do a little cross multiplying here. So in other words, I would have to multiply this C over to here. I'm multiplying the 12 over to here, and then I got to divide that sine 27 over to the right as well. So here's what that's going to look like. So I'm essentially cross multiplying and then dividing the sine 27 over to the right. So I'm going to get sine 12 sine 130.8 on top over sine 27. So that's kind of the exact format. Put that into our calculator and we'll have side C. Which is about 20. Oh, sorry. I didn't realize I was off the screen on that one. So I just typed in my fraction, getting about 20. So there we go. So anyway, so if we needed to, we could now fill in all the parts for what we just found. Because one thing I want you to keep in mind, and this is a way of checking answers, to know that you were at least on the right track within the process that you took. So this guy was about 20. You guys learned back in your geometry days that in any triangle, the smallest side is always across from the smallest angle, and your largest side is always across from the largest angle. That is a super simple check just to make sure that your numbers are at least on the right track, right? It's still possible we could make a mistake somewhere, but if I took a major wrong step in my process, and I would tell that some of those rules are not holding true, that was at least a guide for me to know that I made a mistake somewhere. So keep that rule in mind. It might help guide you through a mistake that could come up. Okay, so here is the ambiguous case. So we are given, again, two sides and an angle. This fits our side-side angle scenario. So we are potentially looking at two different triangles. So here's the way they drew it. And I kind of like their drawing, so we're going with theirs. The bold line is the triangle, right? The dotted line is like the other way that we could have drawn side CB. So here's what we're looking at. I got my 35 degrees, opposite side is 10, adjacent side is 12. So this fits the description that the opposite side is smaller than the adjacent side, which means I have to consider two possible triangles here. So either this 10 could be drawn here, or that 10 could be drawn here. And notice in doing that, I'm not changing any of the values. This is still 10, that's still 12, and that's still 35, right? And so if you look at this bold triangle, here's the other way that it could have been drawn. So we do have to come up with a little extra information here in order to cover the whole thing. So we are going to start out with the main triangle that we see here. Okay, they're all acute. Okay, and so we're always going to find the acute one first whenever we do this. Typically when you do this stuff in your calculator, that's kind of what comes up anyway. So we're going to start out by setting up our proportion. Sine 35 over 10 equals the sine of B over 12. So here's that proportion that was set up. Again, we're going to cross multiply and solve for angle B, and they came out to be about 44 degrees. Okay, so in the first triangle, if B is acute, in the acute version, it's 44 degrees. It's very simple when you get down to this lower part. In the acute version, if it's 44, the obtuse version is just 180 minus this. They're always supplementary. So once I know the acute version, subtract it from 180, and that'll give us this guy, which is the obtuse version. All right, let's keep going here. So let's state the next obvious. I know these two plus angle C should add up to 180. Okay, so if I add those guys together, what are we looking at? 79. Subtract that from 180, and we get 101. So in this drawing, angle C is 101 degrees. And then I have one last step of using, I need one more proportion in order to get my third side. So we'll move on down to my version of the drawing. So we figured out this was 44 already. Just figured out this is a 101. And so now we're figuring out side C with one more proportion. Same steps that they took right there to get side C, 17.1. Okay, so we completed our first triangle. So now we have to consider the other option. And so here was the other way that it was drawn. Again, in order to figure out angle B, the obtuse version of angle B, it's simply 180 minus the acute version. So we're seeing that 136 is the alternative option here. So could potentially be 136 degrees. Once we've done that, the rest of this is just no different, right? I'm still going to subtract those two angles from 180 to get my third angle. So I already have that set up right here. So I'm going to do 180 minus 35 minus 136. And what would that give us? 9 degrees. A nice tiny 9 degrees for angle C. There we go. Going on down to just using our proportion to set up for coming up with side C. Again, they're just going to do the sine of 35 over 10 equals sine 9 over side C. And so that's where this step came from right here. So just one more proportion to figure out that this side C is 2.7. And again, guys, one thing you'll notice on this is the largest angle is across from the largest side. Smallest angle is across from the smallest side. Just something I'm always checking for as kind of a way of making sure I was on the right track with my answers. All right. And this is the last one we're going to do for this section. All right, so let's end on a word problem because I know everybody loves word problems. So let's do one of these together. So we got Ranger Station A cites a fire that's 32 degrees east of north. So here is Station A. And if you kind of consider our compass drawing that we've taken a look at before. So here's our north, south, east, and west. Let me raise that up a little bit. So if it said 32 degrees east of north, so here's north, to the east would be this direction, and it's 32 degrees that direction. So that makes this 32 degrees. And then we have Ranger Station B, which is 10 miles east of A. So if I go directly east from A, I get Ranger Station B. And it said that this one is 10 miles directly east. So we're getting a side length right there. And he sees the same fire, so same fire, on a line that's 48 degrees west of north. So this guy, so I'm going to draw that right there. So up here's our fire. That's my fire. Kind of looks like a bush, but we know it's a fire. So this one said 48 degrees west of north. So again, if this is my kind of my compass settings, so if this is north, if I'm going to go 48 degrees west of north, so now I need to go towards the west because of the way that was worded. So here's our drawing for the triangle. We're looking at for the distance from each station to the fire. So I need to know what this distance was as well as that distance. So let's just, once the drawing is done, it really becomes exact same as what we've been doing this whole lesson. So one thing to keep in mind is this is obviously 90 degrees from north to east. And so if that's 32, we are left with 58 degrees right there. Same issue over here. We're going to be left with 42 degrees. Again, you'll notice on this one, this is not the side-side angle scenario. This is a angle-side angle scenario. And so all we have to do is find our missing side lengths. So I'm going to, if that's station A, I'm going to call this side A. And from station B, I'm going to call that side B, just so it kind of fits the model that we've been doing all lesson long. Set up a proportion here. One thing we need to come up with first is our missing angle. So if I subtract those guys from 180, let's see, those guys add up to 100, so that's easy. That leaves us with 80 degrees right here. Now we can set up a proportion. So I'm going to say sine 80 over 10 equals sine 58 over A. So again, all I would have to do is cross multiply, and I'll figure out my missing side right there. I'll let you guys do that one on your own. That's just calculator work. Let's set up the final segment here for B. So again, I'm going to use the same given information of 80 over 10. And we're going to compare that now to the sine of 42 over the opposite side, which I'm calling side B. And again, same process that you would do here to finish it off to find your last missing segment.